Okay, so constant rate of change. Um, our goal today, is to take some information. It could be a table, it could be a graph. If it's a table, we want to find out if the values in that table form a linear relationship. In other words, if I take the XY points, will they form a line? And we want to do this without graphing. Okay? So in order to do that, we have to figure out if there's a constant rate of change. Okay? And so it says determine whether the relationship between the two quantities described in each of the tables is linear. If so, find the constant rate of change. If not, explain your reasoning. All right, so here we go. Let's get started with this. So in order to find out if we have a linear relationship, we need to know if there's a constant rate of change. And so there's a way of figuring this out. So a constant rate of change, write this out. Constant rate of change. We can determine it by figuring out the change in y values I'll just say change in y's over the change in x values. I'll just say change in x's. And it has to be that ratio. Change in y over the change in x. Now, because in math we love symbols so much, instead of writing this out each and every time, there's another way we do this. Whenever we use a little triangle in math, we're finding the difference or change. So it would be change in change in y over change in x. Just this way. And let's study our table here. And let's see if that change is constant, meaning the same. Okay, you ready? So here we go. Let's look at number of costumes. That's going to be our x value. And fabric in yards. That's going to be our y value. So this is fabric needed for costumes. So we have number of costumes 2, 4, 6, 8. And then fabric needed in yards 7, 14, 21, 28. Okay, so we're going to look at the change over as we progress. So we're going from 2 costumes to 4 costumes. What's the change or difference? 2. And it's 2 all the way through, right? Can you see that? We're counting by 2s. Trying to fit it all in there. All right, so the change is 2 every time. That's looking good for us. Let's look at the fabric in yards. We're going from 7 to 14. What's the change there? 7. And then 14 to 21, 7 again. And then 21 to 28. Is this looking familiar? Okay. Well, here we go. Let's figure out. So the change was always the same. Let's look at our change in y over our change in x. Every time it was what over what? 7 over 2. The change was always by 7 for y. So that's 7 yards for every how many costumes? 2 costumes, because the change in x was 2. And that's the part we have to get better at, I think. Putting it into context. What were we measuring on y? Yards of material. What are we measuring on X? Number of costumes. So now, what's the unit rate? Remember how we find the unit rate? That's where the calculator might come in handy. What's 7 divided by 2? 3.5. So in the end, we end up with 3.5 yards per costume. You could say even per one costume if you like. Okay, so we do have a constant rate of change. Turns out to be 3.5 to 1. So now, because we have a constant rate of change, is this relationship linear? Yes. So we're going to say is linear because we have a constant, just fit it in there, constant rate of change. And we'll abbreviate it from now on CRC, if that's okay. So if we ever want to write constant rate of change, we'll abbreviate it with CRC. So we had to answer, is this linear? We could say it is linear because it has a constant rate of change. And what's the constant rate of change? 3.5 yards per costume. Any questions? Okay, let's try the next one. All right, so let's work on this one. So obviously the change here is by 1. Let's figure out the change in the y values. It looks like it's increasing each time, but let's see if it's constant. So if we're going from 21.8 to 43.6, what's the difference? 21.8. How about if we go from 43.6 to 68.8? What's it increasing by? 25.2. A little subtraction and you get that. So last one. What's the last one? We're going from 68.8 to 90.6. 22.2? 90.6 take away 68.8.
22 point something.
No, 21.8.
22.
21.8, I think. Yeah.
Yeah, 21.8. All right. Is it constant?
No.
Not constant. Our problem is here. So therefore, we can conclude this. Non-linear. Because there is no constant rate of change. So if we can't find a constant rate of change, then it's nonlinear. When we graph the points, it's not going to be a line. even though this is our x and this is our y. Okay. So let's try the last one. Let's see if it's linear or not. So go on to number 3. Give it a try. So we can conclude that's not a constant rate of change. So it's nonlinear. So nonlinear again. Because there is no constant rate of change. Okay, on the backside, we're going to do kind of the reverse. We are going to have a linear relationship, but we have to find the constant rate of change. And we also have to figure out if it's a proportional relationship. Do you remember proportional relationships from last year? It's easy. We'll get to it. Okay, you guys ready? Okay, let's turn this over. And here's what we're going to do. We have a graph. We're going to find the constant rate of change. And then we're going to determine if there is a proportional linear relationship. And that really has to do with where this line is going through certain locations. Okay? So here we go. First off, we know this is linear already. We don't even have to check that because it's graphing a line. But what we are going to do is we have 2 points. We have 2 points. All right. So we got 2 points. You see the dots? This one here and this one here. All right. Let's figure out the x and y values. But before we do, let's see what this context is. So this is a hawk diving towards prey. And let's see what we're measuring. On the y-axis, we're measuring altitude in feet. In the x-axis, we're measuring time in seconds. So you can almost visualize what's happening. What's the hawk doing just by looking at this graph? It's swooping down. And we can even measure second by second how high up it is and drop it. Okay? So let's take this top point. Let's figure out the x and y values. So I'm going to start with the y value. So for the y value, I'm going to go this way to the y-axis. And I get 60. Now for the x value, let's go back to that point and look where we cross on the x-axis, or where it hits, I should say. What number is that? 3, right? Between 2 and 4 is 3. So there it is. So it's 3 for x, 60 for y. We'll keep a count of that. And let's go ahead, and I want you to do the same thing for the other point. Find the x and the y values, just like I did. So give it a try. Yes. Yeah. Okay. So what did we get for the y value? Oh, that's the x value, but I'll take that. And 30. So for the x value, it is 6. For the y value, it is 30. Okay. So let's see here. If we're going from 60 to 30, what's the change there? 30. But is it positive 30 or negative 30? Yeah, you're going from 60 down to 30. So you lost 30, negative 30. That's going to be important in a little bit. Now, if we're going from 3 to 6, that's a change of what? Plus 3. Okay. So now what we're going to do is we're going to find our change in y over our change in x. And we're going to add the units to our answer, okay? So our change in y, we said, was minus 30. And what are the units we're using to measure there? Feet. Minus 30 feet. Okay? And the change in x, we went from 3 to 3, we said was 3. And what are the units we're using there? Seconds. So that's in 3 seconds. So the hawk is going down 3 feet every 3 seconds. So if we find the unit rate for that, what is that going to be?
10 feet every 1 second.
10 feet every 1 second. Or dropping 10 feet every second. You can use the word dropping instead of negative. Write that one down too. Dropping 10 feet per second. So we just found the constant rate of change. Dropping 10 feet every 10 seconds. Every second, rather. Now, let's talk about proportional and non-proportional. Whenever you see a graph and you have to determine is it proportional or not, it depends where it crosses the x-axis, or the y-axis, I should say. If it crosses through the origin, remember the origin, 0, 0? If it goes through there, somehow either going up or going down, but it crosses 0, 0, it's proportional. If it crosses anywhere else, it's non-proportional. Okay? So we have to worry about the origin. So here, it really doesn't cross the origin. So we say it's non-proportional. Okay? So let's answer that. We're going to say non-proportional because graph does not cross the origin. And if you're wondering, where's the origin? 0, 0 on the graph, basically. Okay. Let's go ahead and try the next one. All right, you ready? Okay, here we go. We got a point here and a point here. Let's figure out the x-coordinate and the y-coordinate for each of those points. Here's the y-coordinate. Here's the x-coordinate. Here, I better find out what number this is. So how many days are we talking about at this location? 3. All right. Let's look at the context. What are we talking about in this graph? We're looking at book sales. Okay? So we're looking at book sales, and we're measuring sales in dollars on the y-axis and days on the x-axis. So let's see here. Did we increase in sales or decrease? Increase. So how much money did we change over that time? $1,000. So this is an increase of $1,000. Okay, $1,000. And over how many days? 3 days. From 3 to 6 is 3. Okay, so let's find the rate of change. The difference in the y value over the difference in the x value. Okay, I'd like you to find that. Check and find the difference in y over the difference in x. We have all the numbers there. You just have to set them up. And use the units if you can. We're talking about dollars for y and days for x. Okay, so let's come back to this. What was our change in y? 1,000, and it's $1,000, right? Over how many days? So we have $1,000 every 3 days. Let's find the unit rate. Take your calculators and do 1,000 divided by 3. And that will give us how much per day? So $333.33 per day. So that's our unit rate, which is really the rate we want. So the book sales is $333 every day. All right. So that's our constant rate of change. Look at the graph. Is this a proportional graph? Yes, it is. Mainly because it's going through the origin. It's going through 0, 0. If the graph crosses there, it is proportional. So we can say is proportional. Because the graph crosses the origin. Sorry, there it is. It crosses through 0, 0. Now, I'd like you to try the last one. And so for this last one, the graph represents the number of t-shirts sold at a band concert. Use the graph to find the constant rate of change in numbers per hour. Number of t-shirts, obviously per hour. First of all, is it proportional or not? Nope. It would have to cross here at 0. So we're measuring t-shirts on the y-axis, the number of t-shirts, and time in hours. So let's find the difference in y over the difference in x. Okay, give it a try. All right, so what was the difference in the amount of t-shirts? 5 t-shirts. Per 1 hour. And so, yeah, we went from 25 to 30, that's 5. We went from 8 p.m. to 9 p.m., that's 1 hour. So it's 5 t-shirts every hour. I don't know about you, that seems kind of low, right? If you're at a concert and they're only selling 5 t-shirts every 1 hour. I mean, if it was per second, yeah, that'd be nice. But whoever does the merch for this band, I don't think they'll have a job for too long. Okay, so that's the assignment. We are going to have a worksheet. I'll pass it out right now. So in the first question, actually questions 1 through 4. It says determine whether the relationship between the two quantities described in each table is linear. If so, find the constant rate of change and describe the rate of change. Okay, so it's basically what we did on the front page of our notes. So you're going to check the change. And in this case, it is because we get $20 every 2 hours. So if we reduce that to a unit rate by dividing, it's going to turn out to be $10 every hour. And because we did find a constant rate of change, we say so it's a linear relationship. If we don't find a constant rate of change, obviously it's not a linear relationship. So that's the two things you're answering. Yes, it is because here's a rate of change. No, it's not because there is no constant rate of change. And make sure if there is a constant rate of change, figure out the unit rate. Okay? Now look at the two graphs at the bottom. Look at the two graphs at the bottom. Do you notice they didn't give you 2 points like we had in the notes? So what I recommend is pick a couple points. I picked 2 that you can use if you like here, and then 2 here. And then you're going to do the same thing we did on the back page with the graphs. You're going to describe the meaning of the constant rate of change by looking at the units and then saying, is it a proportional relationship or not? One is and one isn't, obviously.